I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question I've chosen to go through here is a long question from 2016 paper 2, and it's question 7. Now you'll notice that this is there's a 3D diagram and a 3D shape that's presented to us. The key to these 3D diagrams is being able to take out a 2D shape. You need to be able to visualize it and just take out a 2D shape like a rectangle or a triangle, or just try and break it down and simplify it into two-dimensional shapes. In the first question here, we're being asked to prove that AC is 1.95 meters. So you'll notice that I've already broken our diagram down into just a rectangle. So the only thing we're concerned with for part A is the base of the pyramid. So my base is CDEF, and it's a rectangle where the distance from C to D is 2.5 meters, the distance from D to E is 3 meters. I can use this information to work out the distance AC. So in this case, you should recognize that the triangle CDE is a right angle triangle. So if I know two sides in a right angle triangle, I can use Pythagoras' theorem to find the third side, or in this case the diagonal. So I can use Pythagoras' theorem to find CE. So Pythagoras' theorem is that a squared plus b squared is equal to c squared. The only thing you have to be careful of here is that c is the hypotenuse, or in other words the side opposite the right angle, in this case CE. It doesn't matter which one is my a and which one is my b. So let's just sub in. Instead of a, I'm going to put in 2.5 to be squared. Instead of b squared, I'm going to put in 3 to be squared. So 2.5 squared plus 3 squared is equal to c squared. 2.5 squared is 6.25. 3 squared is 9. So 6.25 plus 9 works out as 15.25. So c squared is equal to 15.25. If I know c squared is 15.25, I just get the square root of both sides, and I work out that c is 3.9. So 3.9 meters. So my distance from C to E is 3.9 meters. But I've been asked to find the distance AC, which is half of that. So in order to get the distance AC, I'm just going to get my answer and divide it by 2. 3.9 divided by 2 will work out as 1.95 meters. And again, I was asked to show that or to prove it, so I'd put a tick beside it and say that it's true. So again, very straightforward question, as long as you identify which diagram you should be using. In A part 2 of this question, we're told that the angle BCA is 50 degrees. So again, you'll notice that I've extracted a 2D shape from my 3D diagram. I know that the triangle BAC is a right angle triangle because the question says that AB is the vertical height. It mentions that this is a vertical height, which means that the angle at A must be a 90-degree angle. They've told me the angle BCA is 50 degrees, and in the previous part I worked out that AC is 1.95. And in this question, I've been asked to prove that the distance AB is 2.3 meters to the nearest to one decimal place. So we're just going straight back to our junior cert trigonometry. In this case, I'm looking for the opposite and I know the adjacent. If I'm dealing with the opposite and I'm dealing with the adjacent, then I must be dealing with tan. So I can start this question off as the tan of 50 degrees is equal to the opposite, which is x, over the adjacent, which is 1.95. Now clearly the key here is to isolate my x. So if I want to get x on its own, I'm going to multiply both sides by 1.95, which means my left hand side will become 1.95 tan 50. Again, it's 50 degrees, so just make sure your calculator is in degrees as opposed to radians. And if you plug all of that into your calculator, you'll work out that x to the nearest decimal place is 2.3 meters. And again, that's what I was asked to prove, so I put a tick beside it and say that it's true. So my AB in this case is 2.3 meters. In A part 3 of this question, we know AB is 2.3, we know AC is 1.95, and we're asked to get BC. So you should be getting a bit of deja vu from A part 1. It's the exact same question. I know two sides in a right angle triangle and I'm trying to find the third side. So I'm just going to sub straight into my Pythagoras, which is a squared plus b squared equals c squared. In this case my c is BC because it's the side opposite the right angle. So instead of a, I'm going to put in 1.95 to be squared. Instead of b, I'm going to put in 2.3 to be squared. That's equal to c squared. 1.95 multiplied by itself gives me 3.8. 2.3 multiplied by itself gives me 5.29. And that's equal to c squared. So if I add 3.8 and 5.29, I'm going to get 9.09 is equal to c squared. So to get c on its own, I just get the square root of both sides. So I can just say that c to the nearest meter is 3 meters. So in that case, remember, my c represents the side BC. So BC is equal to 3 meters. So that's the third part of my question. Notice how straightforward it has been so far once we identify the correct triangle. So as we continue through the question, we just have to identify which triangle are we dealing with, and then it's just basic trigonometry. In part 4, I'm asked to get the angle BCD. So you should recognize the triangle, or the 2D shape I'm dealing with in this case, is the triangle BCD. Now, in the previous part of the question, we worked out that BC was 3 meters. You should recognize that I can also say BD is 3 meters. The reason I know that these two are the same is because if you look back at your original 3D diagram, it tells me that A is the point of intersection of the diagonals, which means A is at the center of the base of my rectangle, and B is directly above A. So I know the distance from A to all 4 corners is the same, which means if B is directly above A, I know the distance from B to all 4 corners is the exact same. So the distance BC is the same as the distance BD is the same as BE is the same as BF. So all of those 4 distances from B to the corners will be the same. So now, right, so I know 3 sides in a triangle, I have to find an angle. Now, first of all, it's a non-right angle triangle, so clearly, in this case, it's either going to be the sine rule or the cosine rule. Now, if you don't know any of the angles, you can't use the sine rule. So in this case, the only formula we can use is the cosine rule. So my cosine rule is that a squared is equal to b squared plus c squared minus 2bc cos a, where a is the angle I'm looking for, or in this case my theta, and the side, so the small a then has to be the side opposite the angle I'm looking for. So in this case, if I'm looking for this angle, I'm going to sub in this is my a, 3 is my a, and then the other 2 sides are my b and my c. It doesn't really matter which is which, so I'm going to sub in for b, I'm going to sub in 3, and for c, I'm going to sub in 2.5. So just the key in a lot of the cosine rule questions is that if you're dealing with this angle, the side opposite it has to be the side A. But now the cosine rule is set up so that you can find one of the sides. So it's set up so it's easy to find the side A. However, in this case, I want to find the angle. So before we actually sub in for A, B, and C, this question will be made a lot easier if we simplify the formula first. I want to find the angle theta, which means I want to rewrite my formula isolating cos A. So if I just want to isolate this term first, if I just want to have minus 2bc cos A on the right, then I bring these 2 terms to the other side, so it becomes a squared minus b squared minus c squared. Now if I want to get cos A on its own, I'm just going to divide both sides by minus 2bc. If I divide both sides by minus 2bc, the left is a squared minus b squared minus c squared over minus 2bc. So now I've got cos A is equal to this. And at this stage it's still the same formula, but it's just going to be easier for me to find my angle A now. So if I just sub in for the sides A, B, and C here, straight away I'll be able to find the value of cos A. So if I want to find cos A in this case, instead of A, I'm going to sub in 3 squared minus 3 squared minus 2.5 squared divided by minus 2bc, which is minus 2 times 3 times 2.5. And again, they're all numbers, so I can just plug them all straight into my calculator. If I plug it all into my calculator, I get the cos of A is equal to 5 over 12. And now if I want to get, sorry, that should be a theta. The cos of theta is equal to 5 over 12. And if I want to get theta on its own, I just want to bring cos to the other side. So it becomes cos inverse of 5 over 12. And just make sure your calculator is in degrees, because it asked me for my answer to the nearest degree. If you plug in cos inverse 5 over 12 into your calculator, you'll work out that theta is 65 degrees. Okay, so for part 5 of this question, we're asked to find the area of glass required to cover all 4 triangular sides of the pyramid. The key to this question is that all 4 triangular sides are not the same. Remember, the base of the pyramid is a rectangle, not a square. So we've two different types of triangle here. The one facing us, the triangle BCD, and the one facing away from us. So if I get the area of BCD, I'm going to just multiply it by 2. But then the ones at the side are actually equilateral triangles. I know that BD is 3, I know that BE is 3, and I know the base is 3. Which means I know all 3 angles have to be 60 degrees. So the 2 triangles at the side are equilateral triangles. So I want to get the area of this triangle, multiply it by 2. Get the area of this triangle, multiply it by 2, and then that will tell me the area of all 4 triangular sides. So to get the area of a non-right angle triangle, we're going to sub into our formula for a half AB sine C. Okay, so we're taking this straight from our log tables on page 16. So the key to this question is if you're using the angle C, which is 65, then A and B have to be the 2 sides either side of it. So if I'm taking this as my angle, then my A and my B have to be these 2 sides. So in order to get the area of this triangle, it's going to be a half multiplied by A, which in this case I'll call 3, and B in this case is 2.5. So it's the side BC multiplied by the side CD multiplied by the sine of the angle, which is 65. That will tell me the area of just this triangle. But then I want the area of that triangle and the one behind it. So I'm going to multiply that by 2. So if I multiply that by 2 as well, just notice that the half and the 2 will cancel out. But that will tell me the area of the triangle at the front and the triangle at the back. So I can just plug all that into my calculator. And then I want to add the area of the other 2 triangles. To get the area of this triangle, again, it's just the easiest way is a half AB sine C. So in this case, it's going to be a half multiplied by 3, multiplied by 3, multiplied by the sine of 60. Because clearly all of them are the same, so it doesn't really matter which side is which. So it's a half by 3 by 3 by the sine of 60. That tells me the area of the one facing the right, but I also want the area of the one facing the left, so I'm going to multiply that by 2. So this tells me the area of the triangle facing me and the one facing away from me. This tells me the area of the one to the right and the one to the left. And if I add them all together, it works out as 14.59 meters squared. So it asks me to get the area of glass required to the nearest meter squared. So if I round that up, it's going to become 15 meters squared. So my final answer in that case, the area of glass required is 15 meters squared. Okay, so for part B of this question, we're now dealing with an entirely different roof lantern. The difference in this case is that the base of it is a square. In other words, all the sides are the same distance. All the sides are the same length. So in this case, basically the question here is to find the value of one of these sides, or that I've labeled X. But I haven't been given any information other than information about the vertical length AB, which is 3 meters, and the angle of elevation BCA, which is 60 degrees. Now, based on this information, I'm going to be able to use trigonometry to work out the distance AC. So let's call the distance, let's call it Y for the moment. So if I use trigonometry, I'll be able to find the distance AC. If I know the distance AC, if I multiply it by 2, I'll know the distance from C to E. And if I know the distance from C to E, I can use Pythagoras' theorem to find the distance X. So let's just work our way through that question. So one thing I want you to note is, even though it's a question about a 3D shape, we've boiled it down. It's literally just a triangle and a rectangle. That's all it is. So we've boiled it down and now it's just 2D shapes. So in this case, I've got a right angle triangle. I know the opposite and I'm looking for the adjacent. If I'm dealing with the opposite and the adjacent, you should recognize that that means we're using tan. So the tan of an angle, or in this case the tan of 60, is equal to the opposite over the adjacent, which in this case the opposite is 3 and the adjacent we're calling y. So in order to get rid of my fraction, I'm going to multiply y by both sides. So I get y tan 60 is equal to 3. Now in order to get y on its own, I'm going to divide both sides by the tan of 60. So that means the tan of 60 is, y is equal to 3 over the tan of 60. And if you plug that straight into your calculator, we end up with y is equal to the square root of 3 meters. So the distance y is the square root of 3. Remember, the distance y is the distance AC. So now we need to think about what this triangle represents in the context of the base of our lantern. The distance from A to C is the square root of 3, which clearly means the distance from A to E is also the square root of 3. So the square root of 3 multiplied by the square root of 3 is just 2 root 3. So I've actually worked out that my distance CE is 2 multiplied by root 3, which is 2 root 3. So the entire distance from C to E is 2 root 3 meters. So now, let's just deal with the right angle triangle CDE. If I sub into Pythagoras' theorem, my only unknown will be x. Pythagoras' theorem is that a squared plus b squared is equal to c squared. The only one that I know in this case is my c squared. My hypotenuse squared will be 2 root 3 to be squared. And instead of a and b, I'm going to sub in x and x. So I can say that x squared plus x squared is equal to 2 root 3 to be squared. X squared plus x squared is 2x squared. 2 root 3 multiplied by 2 root 3 gives me 12. So clearly now I have a very straightforward equation. I just want to simplify it down and find the value of x. So in this case, to get x squared on its own, I'm going to divide both sides by 2. So I'm going to get x squared is equal to 6. And if I know x squared is equal to 6, to get x, I just get the square root of both sides. So I can just say that x is the square root of 6 meters. And that's the format. I was asked to leave it in the form of the square root of a meters. So I'm happy enough I have it in the right form. So I know the distance CD, DE, EF, and FC is the square root of 6 meters.